In this question, we're given n numbers, and we have to pick one and change that into any other number between 1 and 189 such that the GCD of all the numbers in the list are as big as possible. Now the first thing to observe is, let's say we choose to change a1 into some other number. The best value to change a1 into would be the GCD of a2 all the way till an. Using the same logic, if we choose to change a2, the best value to change it into would be the GCD of a1, a3 all the way till an. Now that we know this basically changes the question to be, if you are forced to take one number out of the list to maximize the GCD, what is the biggest GCD you could get? Okay, so now a quick thing to know about GCD is, if you want to find the GCD of A, B, and C, that's the same as finding the GCD of A and B, and then finding the GCD of this value that we just found with C. Okay, so now let's say we have a list of 4, 8, 2, 6, and we want to solve this question. What is the highest GCD we can get? So obviously we know if we take out 8, it's 2. If we take out 2, it's 2. If we take out, so it doesn't matter in this case which number we take out, it'll always be 2. Alright, so if we have two lists, let's say a forward and a backwards, so in this forward list we'll keep track of the GCD until that point with all the numbers prior to that point. So let's say, okay, 4 will just be 4. Now the GCD of 4 and 8 is 4. Now using this rule, the GCD of 4, 8, 2 is the same as the GCD of 4 and 2, which is 2. And again, using this rule, the GCD of 6 and 2 is simply 2. Now in this backwards list, we have the same thing, except we start at 6 and go all the way till 4. So we first start with 6, and then the GCD of 2 and 6 is 2, 8 and 2 is 2, 4 and 2 is 2. So we get these two lists. Now let's say we want to find the GCD if we kick, for example, the 8 out. That's essentially the same as finding the GCD of all the elements to the left and then we find the GCD of that with the GCD of all the elements to the right of that point. So the GCD of all the elements to the right of this point would be here, would be the 2, and the GCD of all the elements to the left of 8 would be this 4. So the GCD of 4 and 2 is 2. So our final answer would be 2. Okay, so now knowing that, let's actually do it. So first we're given an integer n, and now we get a list. So now we read this list in. So now we want to keep track of the forward and the backward. So we have a forward, the GCD has to be less than the number itself, and the numbers can go up to 189, so it has to be integers. So the forward GCD I will save in an array called f, and the backward GCD I'll save in an array called b. So now let's go forward, and then so let's initialize the first element in the forward GCD as the first element in the list, and then for I between 1 and n, the value of f of I is essentially the GCD of the a of I and the previous element in f. And now it's the same logic. So b of n minus 1 is equivalent to a of n minus 1, and then we do for int I equals n minus 2, I greater than equal to 0, I minus I, b of I is equivalent to the GCD of a of I and b of I plus 1. So now we have that 2 list. So initially the lowest possible GCD you could ever have is 1. So let's leave our answer as 1. Does that make sense? Yes. So now that we have our answers 1, we want to see what, so we go Okay, so we go through the entire list, and when I is 0, we don't include A0. When I is 1, we don't include the second element in the list, and so on and so forth. So we want to know what are the left and the right. So the left would be the index minus 1, and so just for sake of sanity, L right is equal to I plus 1. Now in the first case, when I is 0, this would read minus 1, and then that would be an index out of bounds. So if L is less than 0, so we just want to find the GCD to the left and the right. So just say GCD L and GCD right. Then let's set the GCD to the left as infinity, and using the same logic, if right is bigger than or equal to n, then we know that the GCD of right is equivalent to infinity as well. So we'll use these as a flag to know if we are out of bounds. So then we have to check. So now we have to find the GCD values. So how do we do that? So it's essentially, we want to find the value at okay, so if that's the case, and then do the GCD of right is equivalent to, so with the very first element, so it would be all the elements to the right of it. So we look at backwards of R, and use the same logic, we want all the elements on the left because right is out of bounds. So GCD of left would just be a F of left. Otherwise, GCD of left is just going to be equivalent to FL, and GCD of right is equivalent to BR. And then in the end, we're going to check if we hit any of these flags where the right or left is out of bounds. So if GCDL is equivalent to infinity, then our answer is just equivalent to the right GCD. Otherwise, if the GCD of right is infinity, then we know our answer is just equal to the left GCD. Otherwise, our answer is the same as GCD of the GCD of the left GCD and the right GCD. So just I call it answer, leave it answer for now. I'll call this final answer. Okay, so now that we found what the GCD would be if we don't include the ith element, we want to see if that's the maximum GCD. So then we'll do final answer is the maximum of itself with the answer we just got, and then in the end we just output our final answer. So to clarify, this answer that we get here would be the GCD if we remove the ith element, and then our final answer would be the maximum GCD after we do all this process for each of the n elements in the list. So now if you run that, okay, no bugs. If you run this, answer should be 2. Good. Here the answer should be 6, and finally answer should be really big. Yep. That makes sense. Submit. And voila.